Hello and welcome to page 56 on the workbook. And this is the last part of section 6.5 that we're looking at here. So up to this point in this section, we've been looking at one type of improper integral, and that is the type where we're integrating from 0 to infinity. Turns out, though, that there are other reasons that integrals can be improper, and we'd like to investigate just a couple of ways. Right? So specifically, we're going to be looking at these two formulas, and the 2 and the 3, you might hear me use the word type 2 and type 3. Those are two different types of improper integrals. Okay, let's start with the one up here, number 2. So they're asking us to integrate from a to b of f of x dx, and you might look at that and say, well, why do we call that an improper integral? Looks pretty normal. We've got two numbers, a and b. To answer that question, you kind of have to look over here at the picture. There's something special that's going on with the function f. Okay, so if I asked you to integrate that function from a to b, do you see a possible issue, a possible problem that might come up when you do the integral? Okay, notice that there's an asymptote of our function at this number a. Our function is not defined at a. You can see that from the dotted vertical line that we've got. And so if we tried to do this integral that we're looking at over here, we may very well run into problems with that left-hand limit of a. It may very well be undefined when we try to substitute it into our antiderivative. So kind of what we need to do is to stay away from that left-hand endpoint of a, okay, that asymptote. So what we'll do is we'll pick a number that's reasonably close to a little bit to the right of it. We'll call it t. And we're going to integrate from t to b. That should be safe because we're staying away from that vertical asymptote. So we'll start by integrating from t to b. But then ask ourselves, if we integrate just from t to b, does that give us the area that we want? Not quite, because there's this strip of area here that we're missing. Okay, and so what we're going to do is to take a limit to pick up that extra piece of missing area. We're going to let t approach a from the right-hand side, because notice from the picture that t is a little bit bigger than a. If we do that, this number t is going to move to the left. It's going to approach a, and it's going to pick up this missing piece of area that we didn't get the first time. Okay, so in a nutshell, if you run across this situation where you've got an asymptote at your left-hand endpoint, you're going to use this formula to calculate your integral. Okay, and now we want to do the same thing down here with type 3. Okay, and this is sort of the reverse of the situation that we looked at above. What if we had an asymptote at the right-hand endpoint of our function? Well, in this case, we need to avoid the point b, which means that we're going to pick a number t that's close to b, but a little bit to the left of it. Okay, we're going to start by integrating from a to t. That's a safe integral because it keeps us away from our asymptote at b, but then we notice we're missing a little strip of area here, and so to pick up that extra strip, we're going to take a limit as t goes to b, this time from the left-hand side because t is a little bit to the left of b. Okay, and taking that limit is going to pick up this extra strip of area that we missed. Okay, and so here's our definition of a type 3 improper integral. And in the next video, we'll do an example where we actually use one of these formulas to calculate an integral.